Welcome back. In this tutorial, I'm going to talk about how we can read multidimensional data from an Excel sheet. So if it is a vector, a single dimensional parameter, or if it's a two-dimensional parameter which has an index I and j only, for example, it's easy to read from Excel. You can just directly have the corresponding column or a table in Excel and read it. But if the parameter is more than two dimensions, for example, it includes indices I, j, and k, three-dimensional or even more. How can we read this kind of parameters, this kind of data into our CPLEX model from an Excel sheet? So there are multiple ways to do this. I'm going to show today one way how we can do it. And assume that we are going to read a parameter. Let's say it's a cost parameter. And this cost, let's say it is this C vector. And it will have let's say four dimensions. Okay, I, J, K, L, and L. So we are going to use such a four-dimensional parameter. So to do this, what I'm going to show is first how you can have your Excel sheet, how you can set your Excel sheet, and then how you can read the data into your CPLEX. Let me show my Excel sheet for this one and assume that now for this example, this I, J, K, and L indices represents, different ranges. The first one, let's say it is the commodity. So it can be a multi-commodity flow from facilities to distribution centers using different types of trucks. So we have different commodities, and let's assume that this commodity, this range, takes values from 1 to 5. Okay, 5 different commodities. And I will be taking its values from this range. The second one is, let's say it is the facility types. And again, in this case, we have 3 different facilities. So in this example, in order to show you or in order to increase understanding, I selected different numbers, different range values, so that it will be easier to grasp how we do it. The third one is the distribution centers. So we already learned how to define these ranges. I'm not going into the details of these parts, but I will focus on more how to read the data. And the last range, let's assume that it is the truck type, different types of trucks. And let's assume that we have 6 different types of trucks. So as you all know, we don't need to write this, for example, 5 here, but we can define it as a parameter, like the number of commodities, and we can set its value equal to 5, and then we can write this range of commodity goes from 1 to and commodity, right? So, but I want to keep it simpler, so that I am just using these numeric values in these definitions. Now this CIJKL will use these values. Now how we can read it? Let's have a look at our Excel sheet. So this is the Excel sheet that I am going to read the data from. So as we know, as we defined, we have these commodities, facilities, distribution centers, and trucks. So it is important how I set this Excel sheet up. So what we have is, the commodity takes the values from 1 to 5. Facilities takes the value from 1 to 3, distribution center 1 to 4, and the trucks 1 to 6. So this first row here is the cost value for the first commodity, first facility, first DC, first truck. Okay, C111 is 24. And the second one is C1112, which is 43. Actually, as you can see, my data now here is a single column, and this single column, you know, it needs to go through. I have, again, as a reminder, I have 5 commodities and 3 facilities, 4 distribution centers, and 6 trucks. So in total, if I multiply this, okay, it is 5 times 3 times 4 times 6, and it will be 360 in total. And if you look at this data, where it goes down to, it is row 361. So the first row is the header row. So we have 360 data. And I wrote it in this way so that it starts with the first value of commodity, first value of facility, first value of DC, and track 1. Then, as you can see, the track goes to 2, 3, 4, 5, and 6. All others still 1. And then in the next, what happens? The DC turns to be 2. And again, for these 6 tracks, 1, 2, 3, 4, 5, and 6. And DC goes to 3 and track again 1 to 6. And DC goes to 4, which is the last element of DC, and the track goes 1 to 6. And when DC finish, you know, the facility now goes to its next element, so that for all these values, the facility is 2, and then you see the DC and the track again repeats itself. So when we finish up with all these 3 facilities, 1, 2, and 3, then commodity goes to the next value. So we need to write all these 360 data in an organized way to read it in CPLEX correctly. So these 360 values, again, it is just a single column. And I named this, if you go to these formulas and named ranges, so it is named as cost. So I'm going to use this named range to read the data in my CPLEX. This is how I set up my Excel sheet. Actually, I'm going to read only this row. These rows, they are not important for CPLEX. I'm not going to read those values. So you can even delete these columns. It's not important for you. The important thing is only this row now, okay? But of course, having those values, listing those values helps to understand how you write or organize your data. So this is the Excel sheet. Let's save it and close it, and this Excel sheet is under the project folder already. So I have a model file, I have a data file, and I already set this run configuration, and I'm going to read the data from this Excel sheet. Now let's read it. Of course, I'm not going to read it directly into this parameter. What I'm going to do is I'm going to define a temporary parameter, an artificial parameter, and this artificial parameter will have a range of values, you know, from 1 to 360, and it will take its value from my Excel sheet, from the data, and in the data file I'm going to set up to read it from the Excel sheet. And now, why is it this 360? Again, it is the multiplication of the values of these ranges. You can even write like this. It is for the commodity 5 times, for the facility 3 times, for the DC 4 times, for the track 6. So it makes 360, and this is also possible. Now let's read the this temp from the Excel sheet. Of course, first I need to write the command to connect to the Excel sheet connection. Let me say it is the Excel sheet, and then the Excel sheet name, it was multi-dim.xlsx, And okay, so it is multi-dim, so pay attention to these even upper and lower cases. Make sure that you wrote everything correctly, otherwise you will receive an error message. And the parameter is temp that I'm going to read it. I will read it from sheet read, and it is Excel sheet, and it will be cost. Okay. Let me have a quick check. Yeah, we need these parentheses around. Sorry for this. So it should be Excel sheet, and it should be sheet multi-dim, and then we need, yes, of course, this comma over here, and we need semicolon here and here. Okay. Now we have this CPLEX file, and it should read this temp. Let's run it. We don't have any model, but still we can run to check if we read it correctly or not. So for this one, I'm going to go to this and right click and say run this. If we receive any error messages, we know how to correct it. So it says that we have an error here. Okay, we need to of course say that this is a parameter and this is an integer parameter, and for now I'm not reading this one. Let's turn this off, comment it, and let's run this. Okay, again there is another, and we have this temp. It says that unexpected sheet read or read. Okay, sorry. So this should be capital. You see, when you write it, even the case is important, case of the letters. If you write it wrong, you will receive these error messages, but it is not important. You just need to know how to correct this. Okay, now you see it read, and in the solution problem browser, we see the temp, and let's see, you see the temp, it goes from 1 to 360, and we can see all the rows here, and you can check this if they are correct or not, comparing with the Excel sheet. This is the first step. Okay, so we have this artificial parameter, and we read that artificial parameter correctly. Now, but we cannot use this temp as IJKL. We need to split it. And how we are going to split it? We learned already how to write scripting code. So we will write this execute statement, and in this one, so what we are going to do, I will have a counter that counts from 0 to 360. Okay, so this counter will be used to identify the correct row, correct element of this parameter temp. So I'm going to define this as a var, and let the name be count, and initial value, let it be 0. Okay, now for this one, since we have 4 dimensions, 4 ranges, or this cost includes C, I, J, K, L, 4 indices, I'm going to have 4 loops. And how many? 4 for loops. And the first for loop, let's say it will be for I, and it is in commodity. Okay, and this is the first loop. Of course, this one will be closed after our operations. Okay, the second for loop, so it will be nested for loops for each parameter. It will be for in this J in facility. Okay, and again open this parentheses, and then the next one will be for K in DC. So these commodity, facility, and DC, they are already ranges. And then the last loop is for var L in truck. Okay, and open up. So what do we have inside? What we are going to do? We are going to set the values of this parameter ijkl. So we write cijkl and make it equal to the value of temp, but which value? It will be the value of this count, so counter. But just before this one, I'm going to increase the value of counter by 1. Okay, so let's try to figure out what's going on. So we start with counter 0. When it comes to the first element here, the counter becomes 1. So everything is 1. See, 1, 1, 1, 1 is equal to temp 1. Okay, then it goes to this one, which is the truck L. So it will be 2. So 1, 1, 1, 2 will be equal to temp 2. And then 1, 1, 1, 3, temp 3. So it will go in this way. Once it is done with this truck, which is 6, it will go the previous loop for which k value will be equal to 2. So it will be 1, 1, 2, 1 will be equal to temp 7, and it will go in this way. So the order of these for loops, the nested loops, is important. So at the top level, it should be the first column in your Excel sheet. In the second level, second column in the Excel sheet, and the third and the fourth corresponds to the third and fourth columns in the Excel sheet. Now let's have a look at this one. Of course, we need to close this execute also, and let's have these semicolons, and we have 4 loops, we have 4 parentheses, and for the execute we also have. Also, it's a good practice to write these definitions. So this closes the for loop for L, this closes the for loop for K, and this closes the for J, and this one closes for I, and this one closes the execute. Okay, so let's try it. Run this one, and then it reads the data from Excel first into this temp, and then it will split to this cijkl. Of course, it gave us an error. If you look at the error, C does not exist because we forgot to define it. First, we need to define it as CI, which is the first element, first range, commodity, then J, which is facility, and then the next one, which is DC, and then the next one, which is truck. And we are not assigning anything yet, just close it with semicolon and run one more time. Again, it reads into this temp from the Excel, and then it splits using this code. Let's have a look at this C. Okay, now it is commodity, facility, DC, and truck, and you need to have exactly the same rows in the Excel sheet here. And now in your model file, when you write your model just below here, you can directly use cijkl because we already made the assignments. I hope it's clear. Now I showed this example for 4 indices. Of course, you can have different numbers, 3, 5, 6, and it means that you just need to change how many loops you have here, and also you need to set your Excel sheet correctly, set up your Excel sheet correctly according to this one. Otherwise, everything will be the same.